In this video I want to do a little bit more with partial fractions and show a couple that maybe take a little more work. The first thing I want you to notice here is that this is what would be called an improper fraction. An improper fraction is one where there's more on the top than there is on the bottom. The higher power is on the top. When you're doing integrals, if the highest power isn't on the bottom, you have to do polynomial division first. So even if this were just x squared plus 4x, you'd still have to do polynomial division. So let me do that first. So we're going to have x squared plus 4x plus 3, x cubed plus 4x squared. I like to have the kind of place markers after that, 0x plus 0. So now, x squared multiplied by what is x cubed? Well, it's just x. And we do that times each piece. X times x squared, x times 4x, x times 3. So x times x squared is x cubed. And I'm just going to line them up below the terms, the like terms. X times 4x is 4x squared. X times 3 is 3x. I'm going to subtract. And you'll notice that these first two completely cancel. That's the goal every time, is to get those first ones to cancel. But these next ones cancel as well. And 0 minus 3x is just negative 3x. Well, x squared doesn't multiply into negative 3x. You can't take x squared and multiply it by a whole thing and get negative 3x. So we can stop. This is our remainder. So I can rewrite this original integral as x plus negative 3x over x squared plus 4x plus 3 dx, like that. So now it ends up looking like something we can use partial fractions with. And again, anytime the highest power isn't in the denominator, you have to start with polynomial division. Okay? I'm going to actually even rewrite this integral one more time down here. I'm going to rewrite it as x dx plus negative 3x over x squared plus 4x plus 3 dx. And of course, this first part is a very easy antiderivative. It's just going to be 1/2 x squared. But now let's kind of go over here on the side and deal with the partial fraction piece. Okay, so we can factor the bottom to be x plus 1 and x plus 3, right? So we could have a over x plus 1 plus b over x plus 3 is equal to negative 3x over x squared plus 4x plus 3. Okay, our next step, we multiply a by x plus 3, multiply b by x plus 1. Of course, if I do that, the denominators are the same, so now it's just equal to negative 3x. So we pick our two easiest spots here. X is equal to negative 3. So negative 3 plus 1, we have negative 2b equals 9. So b is negative 9 over 2. Okay. The other easy one would be negative 1. That means that 2a is equal to 3. So a is equal to 3 halves. So now, let me go back. I'm even going to do the antiderivative. So 1/2 x squared plus, so a was 3/2, so it's going to be 3/2 over x plus 1. I still should have the integral there, like that. Dx plus -9/2 over x plus 3 dx. Well, I like to bring my constant multipliers out front. So put a 3/2 there, put a -9/2 there. So when I actually do the antiderivative, I'm going to have 1/2 x squared plus 3/2 times the natural log of x plus 1 minus 9/2 times the natural log of x plus 3 plus a constant. Like that. And that's my antiderivative. Now this one, again, we're going to have to start with polynomial division. I threw this one in because there's an extra little step at the end that we'll get to, but I think another time of polynomial division is probably good. So let's just do that right over to the right here. We're going to have x squared is 2x plus 1 dividing into x cubed let you just put in those place markers. So x squared multiplied by what is x cubed? Of course, it's just x. X times x squared is x cubed. X times -2x is -2x squared. X times 1 is x. Subtract. This is gone. 0 minus -2x squared is 2x squared. 0 minus x is -x. So now we go again. X squared multiplied by what is 2x squared? Of course, it's just 2, so we have a plus 2 up here. 2 times 2x squared is 2 times x squared is 2x squared. 2 times -2x is -4x. 2 times 1 is 2. We subtract. This is gone. 0 minus -4x is 3x. 0 minus 2 is -2. And at this point, x squared will no longer go into what's being divided here. So we're done. This is our remainder. So I can rewrite my integral as x plus 2 plus 3x minus 2 over x squared minus 2x plus 1 dx. So of course that first part's real easy. It's just going to be 1/2 x squared plus 2x. That's this is a real easy antiderivative. This we're going to have to use partial fractions. Always check substitution. If I made x squared minus 2x plus 1, d would be 2x minus 2. So it's close, but it's not exactly it. But I should always check substitution. Well, here's the problem, and what makes this one interesting is when I factor the bottom, it's x minus 1 squared. So this is a special situation where we have what's called a repeated linear factor. Okay, repeated because it's squared, linear because it's just a linear, x minus 1 is a line with a slope of 1 and a y-intercept of -1. So this is a little bit different. Okay, so this one is not usually on the AP exam, but I thought it would just be kind of fun to look at. How we break this thing down, okay, let me put this over here. We still do a over x minus 1 plus b, and this is where it changes, over x minus 1 squared. Okay. Now, I think you're going to see why we do that here in just a minute, because of course we're going to need to multiply this by x minus 1 and this by x minus 1, but we don't have to multiply this b part by anything, because once I've done this, I have the common denominator. So what you're trying to do is essentially do partial fractions without the necessity to multiply both terms. And again, partial fractions is really just breaking this apart and kind of creating a situation where we can break into these two fractions to make life easier. That's what we're doing here as well. So we end up with a multiplied by x minus 1 plus b is equal to 3x minus 2. So we pick the same thing. We say, okay, well, if x is 1, then b, because there is no x there, b is equal to 1. Well, this adds a little wrinkle, though, because now you say, well, okay, x is 1, but what else do I know? Well, we just have to pick another x. Remember, we've always picked the easiest x's, but we didn't have to pick the easy ones. We could have picked any x. But the secret is, we know now that b is 1. So I can just substitute that in right away. B is 1. So let's pick, I don't know, x is 2. Okay? So we go back to a, 2 minus 1 is 1. So 1a plus 1 is equal to 3 times 2 minus 2. So 4. So a has to be 3. So let me just recap this whole thing, this repeated linear factor. Okay, so we had a over x minus 1 and b over x minus 1 squared, and the reason we did that is because since it was a repeated linear factor, we had the same thing. If you had an x minus 1 and x minus 1, then of course when you tried to plug in numbers down here, they'd both be 0 and cancel. So this gives us the situation where we can multiply the a term to get the common denominator and leave the b alone so it won't cancel out later. So a times x minus 1 plus b was equal to 3x minus 2. We plugged in 1 like always, and we end up with b is equal to 1. Well, I substituted that back in right away. I knew b was 1. Then I picked another x. It could have been anything. I picked 2 because I thought it would be easy. So 2 minus 1, so 1a plus b, and I know b is 1, is equal to 3 times 2 minus 2 is 4, so a was 3. So now, since I know a is 3 and I know b is 1, I mean, we can probably do some pretty easy substitution stuff with this. Let me just kind of go down here. I'm going to do the integral of x, so 1/2 x squared plus 2x plus, and let's see, a was 3, so 3 over x minus 1 dx plus 1 over x minus 1 squared dx. Bring the 3 out. This one's now easy. This the other one might need substitution. You might need to think, well, if I made u equal to x minus 1, du would be dx. Essentially, it's x minus 1 to the negative second, or u to the negative second. So let's go through here. 1/2 x squared plus 2x plus 3 natural log of x minus 1 minus 1 over x minus 1 to the, or x minus 1 plus c. And how I got that was, if this was u to the negative second, raise the power to negative 1, divide by the new power, makes it negative. So here is our integral.